Hi folks, welcome back to the lab. So I was doing up some oranges here for some orangeade, and for some reason my oranges are really dry. So out of about 6 oranges, I was only able to get about a cup of juice here. So I thought that was kind of a shame, and I was wondering if there was some way that we could convert this dry matter. So the first thing I'm going to do here is try to extract all the usable fiber from this. Hopefully that'll be enough water. We'll just stick that on the blender and see if this thing can pulverize up or not. Alright, now that we got all that blended up, we have this slurry of orange fiber, which probably tastes fantastic. It's very tasteless actually, but it does have a little bit of an orange flavor, which is a good thing, I guess. We're going to add this pectic enzyme to it. What this is usually used for is in winemaking, and what it does is it breaks down any residual starches, but normally juice doesn't have that much starch in it, whereas this is like entirely starch. So we're going to add a little bit more of this stuff than we normally would. Just add it straight in there. I'm thinking since there's so much starch content in here that it might just take several days for this all to convert. And I'm trying to figure out how to prevent this from souring. I could put it in the fridge, but that would make this reaction take a very, very long time, probably weeks or something. So what I think I'm going to do is add sodium metabisulfite to this. Alright, we managed to get exactly 1,500 grams of this stuff, which means that 1,000 of it was water and 500 of it was our orange fiber. This sitting here might just go bad after a while, so I'm going to be putting in these Camden tablets. These are tablets made of potassium metabisulfite. Normally you want to use 1 tablet per gallon, and I think we have about 1/3 of a gallon here. Let's go with 6/10 of a gram. That means we need 2/10 of a gram of potassium metabisulfite in that bottle. We're going to get that mixed up with some distilled water, just enough to dissolve that. And we'll just pour that into here. As for the dosage of sulfites and other toxic stuff that might end up in this, it's going to be very low, so I'm not really too concerned about it. Because people that make wine usually do several doses of this. The only reason I'm doing this is to prevent there from being some kind of bacteria that get to the drink before I get to it. But anyway, this is going to sit here for a few days and we'll see what happens to it. Alright, so it's actually been 10 days. I let it sit a lot longer than I had originally planned, but that's alright. As you can see here, a couple things to note. There is a pretty large layer here that was forming out about 5 days in, but this is definitely more pronounced now. This bottom layer is very clear. It's kind of hard to see with the lighting, and the top layer looks like mostly fiber. But there's another thing that I'm really concerned about, and that's the gas that you can see in here. That's not supposed to be there. Oh, yeah, it definitely did off-gas a bit there. It was under pressure, which is not quite right. I'm not getting any sulfur from that, which is weird. It's a little bit composted smelling. Like a partially rotten orange, but it's not quite rotten. Definitely some CO2 gas, which is really weird. I'm not expecting there to be CO2 in this. Maybe this is some kind of wild yeast. It's real chunky. This will stop right there because I'm going to start pouring off some of the top layer if I keep going. It actually smells pretty much fine. It smells like a really weird mead. It honestly smells fine. Like, that's totally normal smelling. It doesn't smell like it's rotten, although a normal orange should not smell like this at all. I've smelled things that people actually drink that smell like this. This is just made with feral bacteria, though, so this is not safe to consume. That being said, I will try some of it anyway. I'm just not going to drink this, and I will rinse out. This is not suggested. Do not try this at home, because this is how people get botulism, basically. All right. It's very interesting. What I said earlier about the gas and the CO2 being in this thing was totally right. This does taste a little bit fermented. Like, not fermented like sour, but it tastes like it has a little bit of fizz in it. So I think for sure there was some feral yeast that got into this thing. But on top of that, there's definitely some kind of like uh, some lacto or something in here because this has a little bit of a tang to it. It's very minimal, but compared to how this tasted before, which is basically straight water, there's a slight tang. I definitely would not recommend drinking this though. All right, so conclusion time. This tastes pretty bad. Well, it smells like mead, like some mead that people put fruit in, and it's like kind of got that like slight fruit and slight lacto smell to it. So if I were stupid, I'd probably drink this. But there's a very minuscule chance of botulism. I don't want to risk it. So I would definitely consider this to be a fail. If you want to make your own sugar, this is definitely not the way to go about doing it. This doesn't really convert the mass into sugar. I mean, it kind of does, but what it's doing is it's taking the pectin and chopping it up so that it doesn't form like the cohesive glue that it forms inside the cell. The cells sort of break apart and they'll release the contents. The stuff inside of it has more sugar, and that's why you get more yields from your grapes using pectic enzyme. This, though, is not a beverage, that's for sure. Some observations, though, it's not very sweet. It's not as sweet as I was expecting. And that could be one of two reasons. One is it didn't actually release very much sugar. Pectic enzyme doesn't really convert pectin into sugar per se. It converts it into like big sugars that don't have very much sweetness to them. That makes any sense. Another thing is some of the bacteria that got into this stuff could have eaten most of the sugar out of it. So while the enzyme was doing its work, the sugars were probably just being consumed by the bacteria. And about that, I think I have an idea why bacteria got into this thing and yeast, because I opened this bottle around 4 or 5 days into it, thinking that I should probably let off some of that noxious gas. But I probably should have left it in there because that noxious gas is actually what kills off the bacteria. It has kind of a weird mix between a pleasant and an unpleasant odor. I am kind of curious to see how far this will go if I just let it sit in a cupboard for a while, but I think I'm just going to end up pouring this out. I think what's in there right now is going to end up making a bunch of acetic acid and a bunch of other stuff it's just going to be vinegar by the time it's done. Unsafe to drink vinegar. But anyway, I do want to repeat this in the future using something like cellulase, because that will be much better at breaking down the cell walls and maybe even converting some of the starch into real tasteable sugars. And that's also how they make some sugars from things like corn. They just extract it with cellulase. But anyway, that's going to be it for me today. Thank you very much for watching. If you watch this crazy random stuff on the channel, that's going to be it for me today. Thank you very much for watching, and I'll see you next time.